In this video, we're looking at transversals and parallel lines. First, a little bit of terminology. Transversal is a line that intersects two coplanar lines at two distinct points. So there's the transversal. Corresponding angles are two angles that are in the same place with respect to the transversal, but on different lines. So angles 2 and 6 are corresponding, and 3 and 7, and there are a couple of other pairs like 1 and 5, 4 and 8, etc. Alternate interior angles are two angles that are in the inside of lines L and M, but on opposite sides of the transversal, like 3 and 6 and 4 and 5. Those are the only two pairs. Alternate interior angles are two angles that are on the outside of the pair of lines L and M, but on opposite sides still of the transversal T. So this would be angles 1 and 8 and 2 and 7. Same side interior angles are two angles that are on the same side of the transversal T and on the inside of lines L and M. So this would be angle 3 and 5 and 4 and 6. There are also same side exterior angles, and we'll take a look at an example of that later. Okay, so let's try an example problem. We have two coplanar lines in a transversal, and I want to find the corresponding angle to angle 4, which is angle 6. Next one, the alternate interior angle with angle 5, that would be angle 3. Corresponding angle to angle 8, it's in the same relative position, that would be angle 2. Alternate exterior with angle 7, that would be on the opposite side of the transversal but outside the lines, that would be angle 1. Alternate interior angle with angle 4, that would be angle 8. Same side interior with angle 3, so that would be on the same side of the transversal but inside the lines. That would be angle 8 again. And the angle that corresponds to angle 1 would be angle 5. So again, interior and exterior of the two coplanar lines. Okay, let's do some postulate writing here. Corresponding angles postulate. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So angle 1 and angle 5 would be congruent. Angle 2 and angle 6 would be congruent. Angle 7 and angle 3, and angle 4 and angle 8. So again, these two coplanar lines here are parallel, and this is the symbol that denotes parallel. Okay, alternate interior angles theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Again, congruent for this one. So angle 3 and angle 6 are congruent, and angle 4 and angle 5. They're the only two pairs for that one. Alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So we have angle 1 would be congruent to angle 8, and angle 2 would be congruent to angle 7. So the first three are congruent. The second two are a little bit different. Same side interior angles theorem. If two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Supplementary means the two angles add up to be 180 degrees. So that means the measure of angle 3 plus the measure of angle 5 is 180, and the measure of angle 4 plus the measure of angle 6 is 180. Same side exterior angles theorem. If two parallel lines are cut by a transversal, then the same side exterior angles are supplementary. So that would be angle 1 and angle 7 would add up to be 180, and the measure of angle 2 and 8 would also be 180 or supplementary. So we have two groupings here, congruent and supplementary. Corresponding alternate interior, alternate exterior angles are congruent, and the supplementary ones are the same side interior and same side exterior. Okay, so let's do some example problems. Find the measure of the angle and x. So we look at these two angles and we see that these are alternate interior angles, and we have two parallel lines and a transversal, so they are congruent. So I can set it up as 4x minus 10 equals 58. Solve for x. It's a two-step problem, and I get x equals 17. Now I can substitute that back into the problem, but I'll see that the other angle will also be 58. Example 5, find the measure of angle 1 and 3. Well, we know that angle 2 and 47 are alternate interior, 1 and 2 are corresponding, and 3 corresponds with angle 47. So they're all congruent to each other. So angle 1, 2, and 3 are 47. Find the measure of each angle and the value of y. This pair right here would be alternate exterior angles. Again, they're congruent. So set up the algebraic expressions equal to each other and solve for y. And we get y equals 27. Now I can substitute 27 back into one of the expressions, like 7y minus 55. 7 times 27 minus 55 is 134, and the alternate exterior angle will also be 134 degrees. Alright, next example. Find the measure of angle 2. Well, we know angle 1 is 66 degrees because it's alternate interior angles. Angle 2 and angle 66 are same side interior, and therefore they're supplementary. So angle 2 has to be 114. Example 8, find the measure of x. Well, these two expressions are on the same side interior, so therefore they are supplementary. So I add the expressions together and solve it for 180. So I can add my like terms. Solve for x. X equals 35. I can then substitute that into the expression, and I get 67 degrees. And then if I subtract that from 180, I get 113 as the pair. Next example. Example 9. We know that L is parallel to M and S is parallel to T. We want to prove that angle 1 is congruent to angle 16. First, I can say that angle 1 is congruent to angle 9 because of corresponding angles are congruent. Then I can say angle 9 is congruent to angle 16 because of alternate exterior angles are congruent. Then I can say angle 1 is congruent to angle 16 by the transitive property. If angle 1 is congruent to angle 9 and that's congruent to angle 16, then angle 1 is congruent to angle 16. Okay, that's it. I hope you got this little bit of information. Now go ahead and try your practice set problems. See you next time.